prove that if the given equation is true, then we will have the following equation. So we should prove that A divided by B, which is divisible by C divided by D, is equal to A being divided by C, that will be divisible by the quotient of B and D. So as you see, this looks unnatural at first, but there's a way to get there. So first we should start with a given statement. The given statement is A divided by B being divided by the quotient of C and D, and that is A over B divided by C over D. Okay, and the reason for that obviously given. Now the second statement, we have to basically work the right side. Okay, we're going to keep the left side as it is, we're going to work the right side, and we're going to transform the right side into this somehow. Okay, so we're going to copy down the left side always, and we're going to change the right side depending on what we're doing. In this case, what we want to do, we want to express this as multiplication by keeping the first fraction and then flipping the second one, as a result of which this becomes a multiplication. Right? So D divided by C. So the reason for that is easy. It's called reciprocal rule of division. Okay. Now the third step. So now this looks like a product. We should keep the left side as it is without rewriting it. And the right side this time, we will basically perform multiplication of numerators and respective multiplication of the denominators, right? So as a result, we should get something like this, AD divided by BC. And the reason for that is fraction multiplication rule. Fraction multiplication rule. So the next part, copying down the first one, that doesn't change. Now what will change here is that we want to multiply the numerator and denominator by 1 over CD. And notice that can be explained as an identity property of multiplication. Right? Because identity property implies that you have the same quantity being multiplied to the numerator and the denominator. Okay, so identity property of multiplication. Okay, so once we have that, the next step is to, of course, copy down what we have. And what we're going to have here is that, again, using the fraction multiplication rule, you know that you're going to have AD over CD. AD over CD being divided by BC over CD. Okay, so once again, this is going to be fraction multiplication rule. Okay, so now the sixth step, I'm going to save some space here. I'm going to write the sixth step here. Of course, this will not change. But the right side now, what do we do with this now? What we can do with this now is that we can express the top as it is AD over BC, but this time that should be divisible by CB over CD. No, actually, let's do BC divided by DC. So all I'm doing here is that I'm switching the order of this product CD, of the components of this product. So instead of writing CD, I'm writing DC. Everything else remains the same. And the reason for that, of course, is the commutative property, right? Because commutative means that you can switch the order in a product. The product does not change, right? So commutative property of multiplication. Okay, so now that we have that, let's write the seventh step, next step. So this is untouched. So now we will have what? We can basically undo what we did here, right? We can undo that. Basically split up the product AD into individual components A and D. So what I'm saying is we can write A times D divided by C times D. By the way, this should have been CD. I don't know why I wrote BC. So let's correct that. This should be CD. Okay, so this should be CD. Okay, that makes sense. So I'm going to write A times D divided by C times D. And that will be divided by B times C over D times C. Okay, and the reason for that is going to be, again, fraction multiplication rule. Right, we're just using that in reverse, but it's basically the same rule. Okay, fraction multiplication rule. So now the eighth step would be to figure out what happens. So obviously, as you can see, D will be divided by D, right? And A will be divided by C. So as a result, what happens is you can write it as A divided by C times 1 over B divided by D times 1. Right? So the simple reason for this, because we know D divided by D is 1, C divided by C is 1, right? So we know from this that this is, again, just a substitution, right? This is, we can just say this is substitution. Okay, so this is just a substitution. Because we substituted D over D 1 with 1 and C over C with 1. Right, so that's easy. Now the ninth step we'll make it A divided by C divided by B divided by D. Okay? Because 1 times A divided by C is A divided by C. The reason for that is simple, right? It's going to be simply, again, identity property, right? Identity property means that when you multiply by 1, whatever comes before that is still that. That doesn't change, which is, in this case, A over C, right? So this is identity property of multiplication. And finally, the 10th step gives us exactly what we wanted to prove, right? Because if we substitute, we know this can be expressed just like the given statement was. This can be expressed backwards as this, right? So in the same way, A divided by C over B divided by D can be expressed as A divided by C in the numerator divided by b divided by d can be expressed like this, right? So the reason for that is simple. Just say substitution, right? Because we know that these are equivalent. These two are equivalent, these two right sides, right? So we can just say a substitution. So I hope this was helpful and fun. Thank you so much for watching, and see you in the next video.